2016 paper for linear algebra. So 2a, we have two lines L1 and L2, and we have to determine whether these two lines intersect. Then we find the shortest distance from the point 215 to the line L2. The second part of the question asks us to find a Cartesian equation of a plane which contains these 3 points. So for question 2a, we want to know whether two lines L1 and L2 in 3D, whether they intersect or not. So this is the line for L1, this is the equation for L2. So in order for these lines to meet, the x, y, z coordinates have to equal. So the x, y, z coordinates of line L1 are given by the vector on the left, and the x, y, z coordinates of the line L2 are given by this vector equation on the right. If the two equations meet, then the x component of the first line has to equal the x component of the second line, which means that 1 minus r has to equal 1 plus 0s. The second components also have to be equal, so 0 take away no r's gives you 0, and that is equal to the second component on the right hand side, which is 3 plus s. And the final components also have to equal, so 2 plus 3r has to equal 1 plus 2s. So we have three simultaneous equations in two unknowns. Equation 1 gives r is 0, equation 2 gives s is minus 3, but then we have an inconsistency with equation 3. So if you put r equals 0 and s is minus 3, we have a contradiction, so therefore the lines do not meet. To find the shortest distance from the point 215 to the line L2, we suppose that x is a perpendicular point on the line, and the line is given by 1. By 1 is the first component, the second component is 3 plus s, and the third component is 1 plus 2s. So the vector ax would be x minus a. So we take this vector x and we subtract the vector a, which gives minus 1, 2 plus s, and minus 4 plus 2s. This vector is perpendicular to the line, so therefore this vector ax dotted with 0, 1, 2, which is this vector here, that should give you 0. So minus 6 plus 5s would equal 0, so that means that s is equal to 6 over 5. So therefore we can find the vector ax, which is x minus a, and that gives us minus 1, so we just plug 6 over 5 into this for x minus a, that gives us this vector. And then to find the length of the vector, we just find the norm of this vector, which is the square root of 1 plus the square root plus 16 over 5 squared plus 8 over 5 squared. And if we work that out and take the square root, then we get root 69 over root 5. So that's the shortest distance from the point 215 to the line L2. For the second part of the question, we have 3 points on a plane given by a, b and c. So to find the Cartesian equation of the plane, we simply take the cross product of two vectors. So if a, b and c lie on the plane, then for example ab and ac are vectors on the plane. So to find the vector ab, we just do b minus a. So this first row here is the vector b minus a. So b minus a gives us the vector 1, minus 2, and minus 6. And similarly, you can find the vector ac would be c minus a. So this vector here is c minus a. So these two vectors lie in the plane. So to find a normal to the plane, we simply take the cross product of these two vectors, ab and ac, and that gives us this vector. So this is a normal to the plane. So these coefficients here give us the coefficients of the x, y, and z of the plane. So we have minus 6x minus 2y plus 6z is equal to p. Now if we plug the coordinates into this equation, so here we've taken the minus 1, 3, and 2, which is this a. A lies on the plane. So we put a, substitute these points in, and then we find p is equal to minus 45. So the equation of the Cartesian equation of the plane is 6x plus 21y minus 6z equals 45. And that concludes the solution for question number 2.